Alrighty, so we're going to have a look at the sine rule. So basically the sine rule is just a way that we can find missing side lengths on or angles in fact on in some triangles, okay? Now it's mainly used for non-right angle triangles, and at the end of the video I'll show you why this is related to trigonometric ratios in right angle triangles. But what I'll do first is I'll show you how it's applied to non-right angle triangles and how we can do that. Okay. And yeah, we'll go from there. So let's have a look at actually applying this. Okay. So say we've got a triangle, and we want to be looking at non-right angle triangles in this case. Okay, so something maybe like this. Now, the sine rule itself states that all of the sides of the triangle are going to be in proportion to their angles, okay? So what I'm going to do up the top here is I'm actually going to write what the sine rule is. Okay? Now, there's two different versions of it, of the sine rule, okay? But we only need to write one down because the other one is just like the flip of it. Okay? The sine rule is A over sine A equals B over sine B equal to C over sine C. Okay, where the little letters are the side lengths, okay? And the big letters, the big A, B, and C, are the opposite, or the angle that is on the opposite side to where the small letter is. Okay? Now, when you're typically solving a problem or using the sine rule in a non-right angle triangle, you only usually have to use part of this, okay? So I might want to ignore the C when I use this triangle, when I use it for this triangle. So let's have a look at this particular one, okay? And we're going to use the sine rule. Okay, so I'm going to write it out. And I'm going to use this particular one, so A over sine A equals B over sine B. And I'm going to write out, or I'm going to label my triangle with the different positions, okay? I'm going to call this side A, and I'm going to call this side, I'll do it this way. I'll call this side A, and I'll call this side B. Okay, and the sides that are directly opposite, okay, I'm going to call capital A and capital B. Okay, now it's just a matter of replacing the letters in the positions where they are. So my A is my X over sine 80 is equal to 7 over sine 75. Excuse me. Okay, so we've got this statement now, and now to find what my X value is, all we need to do is just rearrange it in terms of X. So what we need to do is we need to move this sine 80 to the other side. So it's X divided by sine 80, so I'm going to multiply both sides by sine 80 degrees. Okay. And so we get X is equal to 7 over sine 75 degrees times sine 80 degrees, okay? And we'll put that into our calculator. So 7, just making sure my microphone was on again. Done a couple of videos without it on. Sine 7 sine 75, tongue twister and a half. 7 sine 75 over sine 80 equals 7 point, and we'll go to two decimal places, so 7.14. Okay, and so that's basically it. So that's what our X value is in this one. Okay, so that's pretty straightforward when it goes to finding a side value. Okay, so you're just using that rule and you're simplifying it like that. Now, when you're doing a uh, when you're doing an angle, it's a little bit trickier. Okay, so what I'm going to do is we're going to do one that looks like this. Okay, so we'll go example 2, and it'll look like maybe something like this, possibly something like this. Um, uh, yeah, we'll do this one. Okay, 40 degrees, and it's going to be 6 centimeters down here and 4 centimeters down here. Now, I'm going to leave some space on the right hand side because I want to show you guys something that you have to check every time you do a sine problem, okay? Especially when you're finding an angle, because there technically can be 2 solutions to this problem, okay? So we're going to write our sine rule out like we did before, okay? But this time, instead of writing A on sine A is equal to B on sine B, we're going to do it the other way around. We're going to write sine A on A, and we're allowed to do this, okay, is equal to sine B on B. Okay, so it's just writing it the other way around, okay? Now I'm going to label my triangle, okay? So I'll call this corner my A corner, I'll call this corner my B corner, and so the sides opposite are little b and little a. Okay, so this is sine theta over 6 is equal to, oh, excuse me. Sine theta over 6 is equal to, and it's sine of 40 degrees over, and it is 4, like this. Okay, so to get that sine theta by itself, we're going to multiply both sides by 6, and we get sine theta is equal to sine 40 degrees over 4 times 6. Okay, and then we're going to do our theta, and we're going to do our sine inverse. And at this point, you could simplify that right-hand side, but I'm just going to put the whole thing in here, okay? So just put the whole thing in like this, okay? And you can put the whole thing in there, like that, in the calculator. And let's do that. So we're going to go sine inverse, and we're going to get, oh, let's have a look. So sine theta, it's going to be 40, or not 40, it's going to be sine of 40 over 4 times 6, it equals, and we get, well, 74, 74 point, or 0.6 degrees. I will write it in degrees minutes. So 74 degrees, and we'll go to the nearest minute, so 37. And now, if you have a look at the picture I've drawn, though, you'll notice that it's not an acute angle like I've drawn. It's actually an obtuse angle, and this is where we have this issue that we've got to check, because if you remember from the obtuse angles lesson from a couple of lessons ago, we talked about sine being positive when in obtuse angles. So like if I was to put in, say for example, into my calculator, so if I put in sine of 150 degrees, I also get this positive answer as well. So what I also have to do is I've also got to check to make sure that this calculation I'm doing down here, okay, this calculation I'm doing down here, I've got to check if it produces an obtuse angle as well, okay? Now, the way I do that is I basically just take my number here, okay, whatever my answer is, and I subtract it from 180 degrees and see if that fits, or see if that works. Now, the only way I can do that is to say, well, okay, so we're going to check for the obtuse now. Okay, so we're going to do 180 degrees, and we're going to minus 74 degrees, 37 minutes. Okay, So let's do it. 180 degrees minus 74. 37. Which is 105. Oops, 100 and... Right, 105. Degrees and 23 minutes, okay? Now, does this make sense that this number can also fit into this triangle, okay? So what I'm basically saying is, can I fit both of these numbers into this triangle for it to make sense, okay? Well, can I put 74 into that triangle, 74 degrees into that triangle for it to make sense? So can this be equal to 74 degrees and 37 minutes? Well, yeah, that does make sense if you think about it, because I can put 74, because 74 degrees 37 plus, 37 plus 40 degrees. Well, that only makes 114. So I've still got some left over to make up this angle here, okay? Whereas if I then say, okay, well, let's try the 105 degrees now. Okay, so this one works, so we're happy with that. Now let's try the obtuse angle. Okay, so can this angle be equal to 105 degrees and 23 minutes, or 40 degrees plus 105 degrees, 23 minutes? Well, then it adds up to 145, and that means that this angle in here, so this does make a triangle that works, okay? So what I'm basically saying is that we can actually make two triangles, okay, that have the dimensions 4 centimeters, 6 centimeters, 40 degrees, okay, with two different theta angles, okay? So the two triangles I could make, so two triangles are, okay, so we've got, so it's like this one here. So this is the first one. Okay, so this is my first triangle I've made, which has, well, it'd be more like this, I'd think. So it'd be something like this, because I oh, how would I draw this? I'm trying to think of how I'd actually draw this one, because we know that, well, I guess it'd have like a really long thing going this way, because this would still have to be 6 centimeters coming this way. It'd be something like this. So it'd be like this. So this angle in here would be 40 degrees, okay? This would be my theta angle, which is equal to, okay, which is equal to my 74 degrees in this particular one. And then I'd also have one that's something like this, something that's got a much bigger angle coming like this, okay? But the difference is that these two triangles, they still have the same three dimensions that I've been given. So they have the same three initial dimensions that, well, I'll do. They have the same three initial dimensions that we were given in the original question. The only thing that changes is that that angle that we're trying to find, okay? And so both of these triangles actually exist, okay? It's just this angle in here is changing based on the information that we could be told. So if it's saying that we're trying to find the obtuse angle or the acute angle, okay, we can actually draw two different triangles. So what you need to do when you're finding an angle is you just need to check, can this angle work? Can this obtuse angle work? And the way you check for the obtuse is you do 180 degrees minus the 74 degree 37, okay? And then work out what that is. And then add up the angles, okay? Now this is important. So 40 degrees in my case, plus 105 degrees, 23. And that's got to be less than 180 degrees, okay? That has to be true. You'll have some triangles where this is not true, and if this is not true, then there cannot be an obtuse angle where this works, okay? And you will see that. But I'm going to leave it there for you guys to play around with, okay? And that's going to be it from me today.